A tiny spherical oil drop carrying a net charge Q is balanced in still air with a vertical uniform electric field of strength 81 pi divided by 7 into 10 to 5 volt per meter. When the field is switched off, the drop is observed to fall with a terminal velocity of 2 into 10 to minus 3. Okay, and G over here is given as 9.8. G over here is given as 9.8 meter per second square. Viscosity of the air is given as 1.8 into 10 to minus 5 Newton second per meter square, and the density of the oil is given as 900 kg per meter cube. Okay, it should not be meter raised to minus 5, it should be meter raised to minus 3. Okay, kg per meter cube, the magnitude of Q will be. First of all, understand that if I consider a oil drop, this is a sort of Millikan oil drop experiment. So when I consider a oil drop, so there will be, when it is suspended in air, there will be two forces acting on this oil drop, mg in the vertically downward direction and an electric field in the upward direction. The electric field, the force due to the electric field will be given as Q, small q into E. In the first case, when the drop is balanced, QE will be equal to mg. Okay, QE will be equal to mg. We have to calculate the value of Q. Okay, it will be mg. Mg will be written as 4 by 3 pi r cube into its density into G. Okay, divided by E, the electric field over here. Let it be as it is. Okay, let it be as it is. I will substitute the values later. I have to find out the value of Q. For that, I know the density of the oil drop, I know the value of G, I know the electric field applied. Okay, the field is given over here. Okay, I know the electric field applied. I have to calculate the value of R cube. So in order to calculate the value of R cube, I will use the second part of this sum. That is, when the electric field is switched off, this oil drop falls with a constant velocity or a certain final velocity, that is the terminal velocity. This terminal velocity is given as 2 by 9 R square G rho minus sigma divided by nu. Okay, over here the density of air is not given. I will neglect that part. Okay, because the density of the air as compared to the oil drop will be very small. Okay, it will be in single digit or in 2 digits. Okay, so I will neglect that part. Okay, so the velocity, so the R square over here will be equal to 9v nu divided by 2g into rho. Okay, so over here it will be equal to 9 by 2 into velocity, the final velocity, the terminal velocity is given as 2 into 10 to minus 3. So it will be equal to 2 into 10 to minus 3. The viscosity in air is given as 1.8 into 10 to minus 5. So 1.8 into 10 to minus 5 divided by acceleration due to gravity is given as 9.8. Okay, the density of the oil drop is given as 900 kg per meter cube. So it will be equal to 900 kg per meter cube. So over here, if I calculate, this is the value of R square. So now over here I will start cancelling out these values. So it will be equal to 2 and 2 will get cancelled out. Okay, 9 and 9 will get cancelled out. Okay, over here I can write this part as, now look at this part carefully. How will I calculate this answer quickly? 1.8 divided by 9.8, this part can be written as 9 divided by 49. Okay, I have divided both of them by 2 and I have multiplied them by 10 into 10 raised to minus 10. Okay, into 10 raised to minus 10. This is the value of R square. So R over here will be equal to root of this part, which will be equal to 3 by 7 into 10 raised to minus 5. Okay, R over here will be equal to 3 by 7 into 10 raised to minus 5. This is the value of R. Now I will substitute the value of R in the first equation. Okay, 3 by 7 into 10 raised to minus 5. Okay, so it will be equal to V over here. Okay, in this case, Q over here will be given as 4 by 3 into pi into R cube. R cube over here will be equal to 3 by 7 into 10 raised to minus 5. So when I substitute this value, 3 by 7 into 10 raised to minus 5 into rho, the rho over here is given as, the density over here is given as 900 kg per meter cube. So it will be multiplied by 900. Okay, G over here is given as 9.8 divided by, okay, into the cube of this part, divided by electric field. Electric field over here is given as 81 pi divided by 7 into 10 raised to 5. 81 pi divided by 7 into 10 raised to minus 5. Let us substitute the values and see how can I get the answer quickly. Okay, so first of all over here pi and pi will get cancelled out. 9 nines are, so this will be multiplied by 9 over here. Okay, so and okay, so 9 into 3 will be 27. So the denominator can be written and the 7 will go in the numerator. So 4 into 7 divided by 3 cube, okay, into 3, this will be cubed over here, again over here, so it will be equal to 3 cube divided by 7 cube into 10 raised to minus 5, the whole cube will be equal to minus 15, okay, into the 2 zeros are remaining over here, which will be equal to 10 raised to 2 into 9.8. okay, so I have solved this part. Okay, so now over here this part can be written as 3 cube and 3 cube will get cancelled out, 1 7 and this will become square. Okay, now over here this part can be written as 9.8 can be written as 4 divided by 49, okay, into 98 into there will be 10 raised to minus 1 again raised to it. Okay, there will be 10 raised to minus 1 again raised to it. So if I solve this part carefully, okay, so over here this is 10 raised to minus 5. Okay, so when I solve this part over here, it will be equal to 10 raised to minus 5 when it goes in the numerator. Okay, this is 10 raised to 5, not 10 raised to minus 5. So there is 10 raised to 5 also over here. Okay, so now it will be equal to 10 raised to 98 into 10 raised to 4. Okay, this will be equal to 10 raised to minus 19. Okay, so this part will be equal to 2 and 2 will get cancelled out, so it will be equal to 8 into 10 raised to minus 19. Okay, 8 into 10 raised to minus 19. This part was electric field over here was 10 raised to 5 and not 10 raised to minus 5. It should be 10 raised to 5. When it goes in the numerator, it will be equal to 10 raised to minus 5. So when I solve this part, I will get the charge as 8 into 10 raised to minus 19, which is over here 8 into 10 raised to minus 19, which is option number D.